Yeah, so by the end of today, you will be able to build this one, and you see how easy it is, right? So it's just like this. So see, we you should be familiar with this one, right? So if it crash to the no, it died. It crash to the pie, and then the actually that's the game over, or the space is so big. No later. So today I just talk for the half of the just 1 hour, and then the second half you are going to do this one. Right? It will be very interesting. So I hope it's more interesting than the last lesson talking about something. Okay. So let me present this one. Okay, so UI kit dynamic. So again, this is at with 8 already. So the reason why we put the thing like until with 7, with 8, because we think that's one is not really important. And you don't need this one for your project. Just it's good to for you to know that one, and you can try this one. Like after this one, you can build the game by on your own, right? Overview on the UI kit dynamic. So it's actually the framework for the model in the real world physics. So it combine everything like the physics law into this framework. So you can use this one for the uh, like the game or the animation. You build the animation. So before, what do we learn for the animation? This were like UI view animation, right? So for this one, we had the same thing, but it will be the uh, like the brand for the physics law for the phone. So it's actually the same physics engine that you use for the Sprite Kit. So Sprite Kit is the one we use to build the game, the 2D game, right? But for the Sprite Kit, this framework will apply to the sprite. So when we build a game, so each object we call the sprite. But within this one, we don't use the Sprite Kit. We just use the UI view, right? So now we learn how to apply the weight and the gravity and the collision, everything to mm, the UI view, right? This is we are going to talk about some of the key key thing on the UI kit dynamic. So the first one, the UI kit animator. So the animator is like this is the brain behind the dynamic in the view. So it actually within the animator, so we can add in everything into this animator. So what we can add in, so like the behavior. So we call it the behavior. So next slide we are talking about the behavior. So in physics, when we're talking about the behavior, so what is the some other thing? Like we had the gravity, like the collision detection. Like for example, if you hit like the bird, it hit to the pipe. So how can we detect that one? That the bird is hit into the pipe, and then we set the weight to the bird, right? If the bird is too heavy, then it hit to the pie, and then the pie may broken. Right? If we can set that one, set like the weight of the bird is very heavy. If it hit to the pie, it's broken. Or something else like push what we try to apply a force, and a fork. That's when we have the strength of the fork and then the direction of the fork, right? So pull and snap is what sandwich when you tap on some place, it will show your item at that place. So like on the screen like that one, I just tap on this one, so it will move the item from its original location to the new location. Right? We also had the attachments and then collision is repeated. Okay. So the animator will be the main one. It cover everything inside. So the next one will be the behavior. So as you can see here, we have the UI dynamic animator, right? And within that animator, we can add the UI dynamic behavior. For example, I want to add the gravity to this one. This is another one. I add the collision detection, right? And within that one, another layer is the child of this behavior. Like I want to add the gravity to the bird, for example, right? So the bird will be the UI dynamic item. Right. So we have the item. When we apply some behavior to the item, right? I apply the gravity to the bird, and then I attach everything. That's attach the behavior into the UI dynamic animator, right? And okay, then we're talking about the item. So this is the smallest item inside the behavior, then inside the animator, right? So item, what will define an item? Like, so normally in physics we have something like where the center of the item, right? Here if we define the UI dynamic item, so it inherit from the NS object protocol, and we had the center. To be able to define the item, we had the center, right? And then the bounds by what? Normally what you have been seen so far is like the square or the rectangular, right? So you had the UI view, you had the UI label, anything. It's like the bound of the item is the rectangular, right? So we had the center, the bounds, and transform. Transform is what? When did we learn this one? Yeah, so transform, there are two transform, right? We had the scale, meaning like zoom in, zoom out the item. And then what else? Another thing is rotation, yeah. Good, so the rotation you want to make like the bird rotate like this way or this way. When it hit to the bar, it should rotate, it should like make some scrolling or something, right? Okay, so here one thing is that we have the one this is the function from the UI dynamic animator. So when we want to update, for example, you apply some new thing on the item and you want to update the item. So this has one function here, update the item using current state. So later we walk through the code and we see how are we going to use the thing. Right. So again, what we need to focus is three things. Right. The first one is what? The biggest one is the animator. Right. Inside the animator we have the behavior. Right. And then we apply that behavior on the item. Right. So three things. All the time, three things you need to remember to able to use this one. Okay. Some of the behavior. So this is the list of the behavior. So as I talked before, we had like the gravity, the collation, something like. So what do we have in the gravity? So normally the gravity will be falling down like this one, right? It's just directly falling down to the earth, right? But if you want to apply some angle, so if not flowing down like this one, but it's flowing down like not perpendicular, but it had the angle to the ground surface. You can add in this one. Another one is the magnitude. The magnitude is actually the acceleration. So by default, this one is what? 9 something, right? On the earth. If you live on the earth, that one should be 9.8, right? 9.8 meter per square per second square, right? And this one you can for example you build your wall. The animator is actually the wall, so you apply on that wall. You have set your own gravity. So you say it is on your own world the gravity is just like 5. You don't want to by default be 9.8, but you don't like that number. You say it's on 5. Or for example, you build the game. In your game you have your like a Superman. Like the Superman can fly very high, and then you set the gravity applied to Superman is like very small number, and then if he jump, he can jump higher than some other object, something like that. Like so, the Superman will be the item, right? And you apply the behavior on that item, but then the animator is the biggest one, so it covers the Superman and also some other item, right? The attachment behavior. So in this case, we use this one when we want to create a relationship between two items, right? Or the item with the anchor point. So we haven't talked about the anchor point. So like if we have some point, we want something to attach to that one. Let me show the example. So we have this one. I want it to run on 5S. Actually, I should show this one easier. It's easier for earlier, so it's easier for everyone to understand. So the first one, like the gravity, like we apply the gravity on the square. So you see, this one it had the gravity and just fall down, right? So this is just by default. I should apply the gravity, and it have the weight, and it falling down to like to the ground, right? This is what the collision and gravity. So we have also had the square, but like you see, it hit to the ground. So now we have the like diode, that's the ground diode, and then your item drop on the ground, and this one we have like the collision and also gravity, right? We were talking about the what are the attachment, right? Where is it? Should be here, the attachment. See, so actually this is we call this one the anchor point. Like I want to attach my square into this point. So if I is it running? Drag anywhere. Why it's not working? Let me try again. Why? Drag what? I don't know. Okay, this one can drag.
It doesn't work because there's a bug. When you find the event for this fourth row, it removes the event from the third row.
Oh, okay.
Because it's the same event, so
okay.
So right now just accept that there's a bug with the third.
Okay, so actually this one the sample code from April.
Yeah, very similar.
Yeah, it 3 years ago. It were back then like 2013. Okay, so again, this is the anchor point, and then when we move the anchor point, we had the square attached to that point, right? So we had some also had the damping effect for the spring, right? Before what do we do with this one? Like what did we use? UI kit animation using spring with damping, right? Still remember that one? So it also had the damping effect, and then when it hit to the wall, you see, oh wow, right? It like okay. See, it hit to the wall. It has some damping effect, right? Okay, so let's get back to this one. Right, so we have the UI attachment behavior. So we have few API here. So either we attach the item to the anchor, or the item to item, or the item to like the center of another item, right? The next one is the collision behavior. So normally how many items do we need to have the collision? Right, at least 2, right? It should have 2. If only 1, then nothing to collide, right? So it should have at least 2 things. And so in this one, if we have the second item, it's okay to have those items hit together. But if we don't have the second item, so if you can see from the second example, so it hit to what? The ground, right? So that's ground we call the boundary. This is not the item, but we set the boundary. So the boundary will be your UI view, right? The whole screen. You set the boundary to be the whole screen, right? So that's one we have the boundary. So you can see here the boundary. So we set the whole UI view, cell.view, right, to be the boundary. So we have when the square drop onto the ground, so it hit to the ground, so it detect the collision there. Okay. Or here you can also like add the boundary. If you want to create your own boundary, it have here the 4 path UI bezier path. Right, you can manually create the bezier path, and then you say, hey, I want that one to be the boundary. So it doesn't necessary. It's not necessary to like hit to the ground. It may hit to something else, like you set that one to be the boundary. Possible, like you say, you just hit on the circle. So your item is within that circle, so it hit to that circle. You can set that one to be the boundary. Snap behavior. Snap is what? This snap. So snap is what? Just you see the square here. If I tap here, it just move, right? And it also has some cool effect that you see the square like it's shaking. It's just not simply move from this point to this point, but it also like have the damping effect and shaking. So cool, right? So here you see the snap behavior. We have 2 things: the destination and then the damping effect. So remember, if we set damping to 1, what does it mean? So the damping is from 0 to 1. So if we set that one to 1, so no damage at all. Like it go there and just very, like it's very heavy, just go there and just very strong, very robust to be stay there. It's not shaking anything. Push. So again, push. We have the force, right, and then the direction, right. So we have here the angle and the magnitude. Like this is how much the force you want to apply to the item, and then the angle is which direction you want to push. So push is what? Push is you have filtering, so you push it instantaneous. Instantaneous is what? Immediately. So you just push one. So for example, if you had item here, you just push, and this one go, and the force is not continuously applied, right? That's why the continuous option. As you use the instantaneous option, it just apply one force, and this one is go. This one the force still stay here. Okay, it's not like push like this. Okay, so is there one note here? If we use the push instantaneous, so the force still sitting there and using up memory. What does it mean? So as I explained, if I use the force to push on that one, and the force still stay here, right? The item is pushed away, but the force still here, and it still stay there forever to use up all the memory, right? So later you have another push, so you put another one here. So we had two push here, one behavior here, one behavior here. So it still stay there forever, right? So it will use a lot of memory. So there one, where that slide? Oh, okay. So it should be about not be here. But this one is the memory cycle avoidance. So this is just the tip to avoid that memory leak when we use the push. So actually we define another one. The push behavior is actually from the original push behavior, but if the mode is instantaneous, right? So here we still set the magnitude and the angle is the same, but we also set the action. So action is this is actually a closure, right? The closure here, and after we apply that push action, we remove it. Right, so after we apply the force to the item, so we just dismiss ourselves. The push behavior will be dismissed, right? And then here we add the behavior push behavior too. So this is just the setup for the push behavior, and then we add the push behavior into the animator. Nice. Everyone clear this one, the yellow one?
But is it also applied on the other behavior?
No, it's not. Like for example, the gravity. If you apply the gravity to the item, it should be all the time. All the time it should have the gravity, right? It's not just at a certain moment, a certain point it had the gravity, and then 1 second later the gravity disappears. It's not the case, right?
How about the anchor?
The what? The anchor? Yeah, the anchor is still there. You in your application, the anchor all the time it appears. You just move it around, right? But it's still there. You still use that one. You don't want to remove the anchor. Right? Okay, so actually this code was from the online call from where is it? The Stanford. So yeah, we had the credit for this one from the Stanford lecture, this online lecture. Okay, let me go back to this one. What else? We were moving. So that's some of the behavior, and then the next thing we're talking about the dynamic item. So some of the property of the item. Okay, here. So like, do you want the item to be rotated? It had the variable here to set it true or false if you want to rotate the item. Like for the bird, you want to hit to the pie, and it should be stay at the same angle. Don't rotate the bird or something, right? And then the friction is what? want to apply some friction, like when the bird fly into the air, it add a lot of friction to the bird, and then it will fly slower, right? Something like that. And then the elasticity, the like the shape, like it's rubber, right? You see the rubber is very elastic, right? So it can how to explain that one? Yeah, straight that one, or on the you had the heavy like the iron square, so you don't want to apply the electricity for this one. Yeah, something like that. What else we have here? So we have some function for the dynamic item. So for example, we say we would like to apply the linear velocity for item. Later we will use this one for the flappy bird. Why? So by default, the bird will be affected by the gravity, right? So by default, if we don't apply any force to the bird, so it will fall down, right? By the gravity. And then when we tap on the screen, what we want to do? To move the bird up, right? So how can we do that one? We add the linear velocity for the item. So we add the velocity with the opposite direction, right? We add the velocity for the bird to go up. And as long as that force is stronger than the gravity force, then the bird can go up, right? So later we use this one. The angular velocity, this one, if something moving like in the circle, right? It's not moving in the the straight line, but it flies, something like that. Okay. Yeah, so this one, the dynamic behavior, still another behavior. So when we say we want to add the child behavior, for some animator we add a behavior and then you add another behavior inside that one. Normally just like the big one will be the animator, then the behavior, then the item. That's it. Just on the case we just use that one. That's good enough. And then the delegate. So the delegate. So they had two delegate for this one. One is the animator dispose, and then another one is the animator will resume. When we use this one? When we will use this one? This is the delegate. So for example, in your games, you want to pause the game, right? Or you playing the game and someone call you, so it's automatically. So in the app delegate, you have something like your app will go to the background, right? And then at that time, you can set you can trigger the delegate to pause your game, right? And later you can resume that. When the app to enter the foreground again, so you use the will resume to resume again, right? We talk about that. Okay, so this is some of the examples. So what is the difference between the three screens? Right, we have one bar, the red bar here, and one gray square. What is the difference between this? So like at first one, we don't apply anything. It's just no gravity and so no collision on this one. And the second one, so we have the gravity on the box and also on the bar. And then in this case, compare the second and the third one. So like the red bar is not attached to the wall, right? So when the box fall in the bar, so it will fall down as well. The red bar will fall as well. On this one, it's attached to the wall, so it drop, but it's not on the center, right? So it's like the box tendency to rotate and then drop down, right? So some of the behavior we apply on the item. Okay, this is just the summary slide. So again, we have the reference view. What is that? The reference view is UI, the cell.view. Normally it will be cell.view. So like it's the whole world, and then inside that world we have the UI dynamic animator, right? So it have the animator here, and then within the animator we can set multiple behavior. The gravity, the collision, the boost, the snap. So those the behaviors we want to add into the animator, and then we apply those things into the square, right? And why we had the slash go to the reference view, right? If this one we set the reference view to be the boundary, and then we want the square, if we hit the boundary, it should stay there. So we set the collation from the item with the reference view, right? The reference view now will be the boundary. Okay. And then in this case, the red barrier, the red bar, we didn't set anything to the red bar, so nothing. Right? So like in this case, we can add another. So like the animator is like the ruler, the one who set the rule for the whole world, and the world is the reference view, right? For example, like Newton, they set 3 rules for the physics, and then everything within this world should follow the rule from Newton laws, right? Then later we have another animator, that's one like Einstein. He said the modern physics, right, is with another set of rules, right? And like let's say someone else say this is the quantum physics, something, and then they can set another rule for their world, right? So we can add the animator, so it will be again the animator is like the brain of the physics engine inside that world, and our world is the cell.view, right? Okay, so now we will try to do some Leaf coding for the UIKit dynamic. For this one, if you go, so for this one, feel free to follow the code if you want. So we will learn by converting the code. If you go to Google and search for the UIKit dynamic catalog, you will see this one. This is the sample code from Apple. So it was like long before 2013, so 3 years ago, and they have actually this is what I just show you right now. So it was written in what? This is what? Objective-C, right? So we will learn by converting this one from Objective-C to Swift, right? Anyone here know about Objective-C? We have few people here know about Objective-C. It should be easier for you, right? And the rest. So if you were worried about Objective-C, so I will walk you through this one, how to read this one, or later if like you read the code from Stack Overflow or somewhere, it was written in Objective-C. You know how to convert other thing from Objective-C to Swift, right? So normally for the Objective-C, what do we have? An H file and then an M file, right? So what is the H file? Anyone who knows the Objective-C? What is the H file? Yeah, the header file, but what it contains inside what? Okay, so if you open the H file, you see here it's stored on the interface here. So we call this one the interface, and then the M file is what? The M file is the implementation, right? So we have this like the H file is just the header of all the function we have, and then this is the M file is actually the implementation of the function you have in the H file. Okay, so here we had one group. It's called dynamic catalog, and then I will try to create a new group I call Swift. Okay, so we convert the Objective-C to Swift directly from their code. So meaning within the code we can have like Objective-C and Swift as well, right? So the first one we convert the easy one first. Gravity view controller. Why is that? Gravity. Right, it just apply the gravity on the square and then the square drop. Okay. So we have Swift here. How are we going to do? So first one will be create a new file, right? Yeah, the new file under source and then CocoaTouch, right? Next. So it will be the UI view controller, right? We want to convert the APL gravity view controller. And then so I say this one gravity view controller. And I put this one into the group Swift. Create. Okay, so at the very first when you create, it's only ask one that you want to create a bridging header. Anyone see this one before? Yes, no? Like so, I don't know if you encounter this one, but if you do the Yelp or the Twitter app, right? If you want to use some of the PDB or what, it will written in Objective-C if you want to import that one into the app. So sometimes it's required to create a header so that you're able to import this one. Right. If you build that one on your own, you might see this one. But it's just ask one. If you say no, then later it will not ask again. Okay, so what is the purpose of this file? Okay, so with this file, so I should create first. So you see here it will have so it will be the name of the app and then bridging header.h. So what does it say here? You need file to import your target public header that you would like to export to Swift. So whatever written in Objective-C, but then you want that function function to be exposed in the Swift, then you use this file. So later you, for example, you say import whatever you write down here, you can import here, and then from Swift you can see the file, and you can actually use the function in that file. So I don't know if I use that one later, just let it there. Okay, so go back to the gravity view controller. So let me open the assistant one view. I move it to the assistant. So at the bottom. Okay, so I will open the gravity view controller.m, right? And then option. Okay, so I have this one, the Objective-C file at the bottom. I will try to convert this one into the Swift on the top. Okay, so what do we need to do? See here, this is what like the IP outlet, meaning we create the outlet for the square, right? If we go back to the view controller, we see no, sorry, the storyboard. So we have the storyboard here. This is what the UI table view controller, and it's the static table, right? We add few cell here for the table, and then each cell is connected to another view controller. So we have the gravity view controller here. It just have one square, and then so we go back to our one. We want to create the outlet. So what is the syntax for creating the outlet? Normally you just drag in the outlet, right? So it just show up everything. So it will be IP outlet, right? And then quick và what else? Square one, right? And then this what? UI image. Is it UI image? UI image view, right? So this line the same, right? We just convert this one into the one. And next one is what? We should create the animator, right? So let animator. What is the type? UI dynamic. Dynamic animator. Right. And what next? You see here, view disappear. Right. So we will set this one into the view disappear. So we don't have that one. So now I can clean up everything here. We don't need it. Just remove it. Remove and then view it appear. This one, right? Okay, so when we override this one, it will be super dot will disappear. When we override something, just call it again, and then we pass in the parameter for the animated here. So animated. Okay, what do we do here? What do we do here? We initialize the animator, right? So how do we do that? Animator, and then what? E. When you see this one, it will, I should copy it, and then see here, init with reference. So from Objective-C, if you anytime you see something like init with or thing like that, just remove the init with, and it will become the Swift. Right. For example, you see here init with reference. The similar thing from Swift is like reference view. Right. It remove all the init with something, just redundant. So you use this one, right? And what is the reference? Cell.view. Right? And then the next thing is we declare the gravity behavior. Right? So remember we need to set the animator then the behavior. Right? Let's say here a chain. Okay. Then let the gravity behavior. So this one what? UI dynamic behavior. And what is the behavior? Now it's not dynamic behavior but UI gravity behavior. So gravity behavior, and then again you see the init width, right? The init width again. So remove that one, it will be just items. So how many items do we have in this world? Just one, right? Only one item in the square. So we put in the square here, so it will be square 1, and it's an array. You see item as like you can initialize with multiple items to add the gravity on multiple items, but in your world now you just have one item. So we have the square there. Then what do we do? Like the animator add behavior, same thing. Animator add behavior, right? And what is the behavior? Gravity behavior. Done. This, and then the last one will be cell dot animator. You go to animator. Done. Anything else? No, I don't think we need this one. Animator. Okay, we don't need it. Okay. You see, this is the Swift. This is the Objective-C, and this is Swift. Seems easy, right? And it like it very neat and then clean, easier to read, easier to follow. Okay, and then after we convert this one, we need to delete it. I don't want it anymore. I only change to the Swift, so I delete this one. So when we delete it, have the remove the reference or move the charge. So we know this one, right? Remove the reference, the file still there. Just remove the reference from the project. I don't want it. I move to the charge. Then later, if I push the code into the GitHub, then people don't see the M file and the H file. I just want this Swift file. So we need to go back to the storyboard, and what is that? Gravity here, right? You need to set the controller to associate the new view controller with this view controller, right? So where is it? On this one, and we set it to be the gravity view controller, right? Okay, so how do we make sure that it's running from our code, not from the code somewhere? Okay, I just print out one line there. Try to run it. Okay, on the gravity, so it's fallen down. Is it? See? So we successfully convert one view controller from Objective-C to Swift. Easy? Not so easy. So we try one more thing. So let's try this one, the collision and then the gravity. Okay, so same thing, right? We add the file here. New file, next, and then it's also inherit is the subclass from the UI view controller, and what do we have here? Collision gravity. Okay, so I had the collision gravity view controller. This is Swift, right? And then what do we do? Same thing, we remove everything here. I don't need it. Let me open the where is it? The no, it's not. Collision. No, APL. Collision. Okay, this one. And then option enter. Okay, so we have it here. Right. What do we do? So we had a view did load. Oh, I should delete it. Never mind. We can do it again. So view did load will be super.view did load. Right. And what do we have here? So I just copy the code from C and I move it here. Easier for me to. Oh, I forget the other thing. So it should be the same with the gravity view controller, right? So I just go back here and just copy the thing. Okay, so we set the image. Same thing, right? Actually, I don't need to use a lot of cell here. It's redundant, right? And this one will be dot image with. What do we have? Image dot what that? The rendering mode. Rendering mode. Image with rendering mode. Same thing, right? And then what is the mode? Is the always template. Okay. Right, we finish this one, this line. The second line, what to set the thin color for the square. This should be easy, right? UI color, and then you convert. You use this one to be the dark color, right? Need to open close parenthesis. Right, so we done the view did load. What next? View did appear. So again, view did appear. Okay, we super dot view did appear. We put the animated there. What do we need? Same thing. We set the animator. We set the gravity. So I just go back and copy the thing. We have the animator here, the gravity here. Okay, so the first step is to add the gravity, right? We have the gravity here to apply the gravity on the square, right? And then the next one is we declare the collision behavior, right? So the next thing will be let collision behavior. This one is what? UI collision behavior, and then item. So what do we set the collision? Also for the square one. Okay, and okay, so what do you see here? We have few things. The first one is translate reference bounds into the boundary. So again, what is your reference bounds? The reference bound by default is the cell.view, right? Your whole screen. So this line means like you want to set that one to be the boundary, right? So from the Objective C it was yes and no, but then when it's moved to Swift it will be true and false, right? So we true. And next one, collision delegate is cell. So when you see the delegate here, it will complain, right? What does complain? It's, you need to make this view controller to be conformed with the this collation delegate, right? So we need the extension. What the collation view and you see what something collation delegate. Where is it? Collation delegate. Okay, right. So we do have, what do we have here? The collation delegate, it have something like, okay, two things. The collation, this one is the what is it? Oh, here, begin contact for item. So when the two things collide together, as soon as it starts to collide, you will call this function, right? And this one is when it's not collide anymore. For example, if you drop the bone, it hit the ground and then it's bound back. So at the moment it's bound back, it no more collide, right? So we need to implement those two functions. It's easier for me to click on this one. We know how to do this, right? So we have here the, where is it? The two function, begin contact and then the end contact, right? So I copy those two functions. Go back to this one. Okay, I remove this one. The first one is the collation, begin collation. Okay, so what do we do here? We do the begin one. Where is it? Okay, the begin one, you will set the thin color for all the square to be the light gray color, right? So be square one dot what thin color to be the UI color and light gray color. Okay, so I just copy this one and same thing here. Remove this to be the dark color. Okay, right, so we run. Oh no, this will not work. Why? We need to set this one from the storyboard. So where was it? It will be the, okay, here, the collation and gravity, right? So click on this one and change to our collation view controller. Okay, so again I go here and I delete this one. We don't need it anymore, so delete it. Move to task. Okay, just to make sure it runs from our code. Okay, print. Okay, time on it. So it, whoa, what happened? Yeah, which one? We didn't add the collation behavior into the animator, right? So when here, right, same thing, we need to add that one, the animator, and then dot add behavior, right? The behavior will be the collation behavior, right? Let's run again. So when we click on this one, it drop, it fall on the ground, and it's like you see some bouncing effect, right? It drop on this one. Though the bouncing thing is well handled by Able already, so it's like the physics engine will handle everything for you. Like if you don't want it to be bouncing, you can set the weight for this one to be very heavy, so when it drop, it just stay there. Right? You don't want this to be bounced back, something like that. We successfully convert to view controller from Objective-C to Swift. For example, something like this one, the 4-1. How do we draw this one? How do we draw the the string is connect from the anchor point to the item? Right, this one, you see when the square is moving, the string will be dynamic, right? It draw based on the location of the the anchor and then the square as well. So we have the able guy, they write one class. Okay, so they call this one the decoration view. Actually, this one is to draw the anchor point and draw the string, the connection from that anchor point to the item. So they have this one. We don't want to convert like very long. This is very long, right? We don't want to convert this one to Swift. Then how can we use in our code? Right? So we have the header here. We want to go back and then we import the what is the name? ABL. What is it? I need to make sure I write correctly. ABL decoration view dot h. Right. So by doing this, we are able to import this one from Objective-C, and then in your Swift, for example, I use this one. I let something like equal to what is it? ABL. Did I save it? I need to save it, and then we go here. It should be autocomplete ABL. See? So now it's visible from Swift. You can see that part, right? Okay, so that's just some example. So now it's your turn to build the Flappy Bird. We still have 1 hour, so try to complete the Flappy Bird and you see how easy is it. So we have the, let me go back to this one on our slide. So if you go to the lab, we have few lab for this one. So the first one will be, is easier, we just finish it, right? You just drop the block, it hit to the wall, the ground, that's it. Very easy, so skip it. The second one is like you draw a slope here, and like you had you create like randomly create the snow. So it's falling, and when it falls to the slope here, like it's your roof, it falling there, and then by gravity it flown to the ground, and when it hit the ground, it like start to melt and it disappear. Right. You also don't want to do that. The spaceship, like you build the game. Right. When you tap on the screen, it will shoot the UFO. Right, and when two things collide, like the bullet hit to the UFO, it will the UFO will be destroyed and disappear. Right, and then I think this one is the interesting one. Right, so now we are going to build the Flappy Bird. To start with that one, we have the, actually we had the instruction here, but this is more detailed instruction. So I post this one into the Slack, and then you can go there. Where is it? You send it? Okay, so Joe just post that one. You can go there and open that documentation. It's actually a detailed instruction to build the Flappy Bird. We already have the image asset here. So you just download this one, you will see the background, the bar, and the bird. So we have few milestones here. Like the first one is just easier to the easy one to add the bird onto the screen and apply the gravity to the bird. So as soon as you run your app, the bird should have the gravity and should fall down. And then some later milestone, you will be able to control the bird to fly. And if you notice this one, it's actually the bird is not moving in S direction. It's just moving in Y direction. The thing moving is the bar, right? The background also not moving. Just only the bar is moving, and you need to control the bird. It's just fly up and down like this one. It's not fly. It's not go forward. It's just up and down, right? And then what else? Like some other milestone, like you want to randomly add the bar and create. Of course, you need to create it. You need to make sure the gap between two bar enough for the bird to go through. Don't make it too big, like too small. Like this one, no way you can get it, right? Yeah. So that's it for the lecture today. So the rest of the time we will focus on the Flappy Bird. So take a look at if you're able to access to the link.